Not to scare you, just be alarming, but 4 out of 10 people in this room at some point of time will be diagnosed with cancer. In 2016, about 1.6 million people in America were diagnosed with cancer, and about 600,000 people, this was reported in that year. If only there is an effective and a cheap method, millions of lives can be saved. So now the question is, don't we already have methods to cure cancer? The answer is yes. However, there are side effects associated with each of these traditional methods. If you think about chemotherapy or radiation therapy, the high dose of drug and high dose of irradiation not only kills the cancer cells, but also it kills the healthy cells. So how do we stop this from happening? How do we avoid the side effects? Is there a smarter way, basically, to kill the cancer cells but not kill the healthy cells? Well, the question is answered as yes. There is a new method which is called photothermal therapy, which is based on application of small particles, which are 80,000 times smaller than the thickness of human hair. And what they do is, when they are injected to the body, they are small and smart enough that they can locate the tumor cells and they can accumulate in that position. When they are irradiated with red light, for example, then they increase the temperature. So now, if you think about it, we have this technique, but we don't know if it's applicable for human beings or not. So what are the important parameters in order to make this technique available for human beings? This is the focus of my research. This is the question my thesis seeks to answer. With the new technique that we developed in our lab, what we can do is we can look at the single particle, which is in this case gold, and we can measure the temperature of single particle, which is about 1/1,000,000th of a meter. If we look at the multiple particles with multiple sizes, and if we measure the temperature for every single particle, what we will realize is that the size of the particles matters how much heat dissipates to the environment. So remember, the question we are trying to answer is, do we still keep this safe for healthy cells? So now, if you have small particles, we will have very good treatment, but if you have large particles, we won't have good treatment because we will kill the healthy cells. So I will continue to develop this technique using these findings. Thank you.